My name is Trang. I'm going to present about a lesson plan to teach the law of conservation momentum, which is that momentum is always constant if no external force acts on the system. Firstly, I will introduce about the context. In previous lessons, students learned the concept of momentum, and I assume that my students are at medium level and they are familiar with the electric vibration device, and they have a chance to learn by increased base learning. The goals of the lesson today is I want students understand the law of conservation momentum and they can gain some increased skills. The first one is they can design the experiment, some key device, and they know how each variable can be observed and measured. And the second one is students can make a decision or explain the experimental process. And the last one is students can manipulate operators to set up and execute the experiment. So now we will turn to the important part with the part 3, teaching and learning. In the part 3, it is including the 3 phases. The first is illicit problem. I will give the student a situation. We consider two cars move colliding each other, and at initial time the car 1 with mass m1 move with velocity v1 to attract firmly with the car 2, which is at rest. After collision, in case of inelastic collision, it means that the car 1 sticks to the car 2, and two cars will move with velocity v. I note for students that two cars move without friction force. So the question is the law of conservation momentum right in this situation? To answer this question, we will move to the next phase. It's phase 2, is solving problem. Because the aim of the lesson is to verify the law of conservation momentum, but this law cannot be evaluated directly by the experiment, so we need to find out the consequence which can be tested by the experiment. In this situation, I have remind student the law that can be expressed P before collision equal P after collision. It is a vector, and in case of magnitudes, we have a P before equal P after. I think that student can verify that M1 over M1 plus M2 equal V over V1. This is because there are no ways to measure directly velocity by the experiment. So I remind students that they instead of measure the velocity, they can measure the distance s and time delta t. This means that v equal s over delta t and v1 equal s1 over delta t1. If the delta t equal delta t1, then this formula can be right m1 over m1 plus m2 equal s over s1. And I focus on some students that it is the consequence which must be tested by the experiment. So the experiment today is to verify this consequence of the law of conservation. If the consequence is correct, so the law of conservation will be realistic. There are some ways to measure S and S1. I remind students of using the electric vibration device, and then I will sketch the experiment on the board. is M2 cut2, and it is cut1. Cut1 will connect it with soft paper tape. Soft paper tape can pass through the slot between the checker pen and the ruler. I will ask students why we need to make an ink check. So because it is very important that we make an ink check to reduce the friction force or neglect the friction force. And then to test the consequence, I will ask a student what variable change and how to measure. And I will discuss with students the experimental process and then ask them to do the experiment several times to take the data and fill the table. This is M1, M2, S1, S2, and we calculate the ratio M1 over M1 plus M2 and S over S1. And now I will do the demonstrative experiment. Firstly, I connected the electric vibration with the power. And then I connect the soft paper tape with the cut1. Sorry. I will measure the weight of two cuts by the balance. It is 170 gram. And the mass of cut2 is 150. And then I will do the experiment. When we turn on the electric vibration device, the checking pen will mark some point in the So now I will calculate the S and, it is S. Calculate in the paper. It is 0.1 and it is 1.1 is 0.6. And then I measure, I calculate the ratio. Zero 0.49. And this is 0.53. It is by half arrows. So I asked the student to do the arrows, and then I conclude that. And I will ask the student what's the reason that make the arrows and how to minimize. And I assume that the arrows here is because maybe angle is quite large. So so the cost growth. Yeah, and then I go conclude the lesson is the law of conservation momentum is state that momentum is always constant if no external force acts on the system, and it can be expressed that through the formula. That's all. Thank you for listening.
Good. So in this case, you only verified the law in only one situation.
Yeah.
So how can you say formalize the conclusions about the conservation of momentum?
Yeah. In this case, I will, as a student, go train the mass M1 and M2 and do the experiment, and then they can find the result by the calculator to test this consequence.
So you will test the consequence in different, a little bit different situations with different mass and
yes.
somehow, but it's still not enough.
I know that there are another case is true cost. Is in case of elastic collision, but with this equipment, we do it is quite difficult because we must have another trickle pen. Yeah.
Okay. So it means that you said that you can tell some story, or describe some other situation with different device, and also some video, for example, when you this in reality, that the application of law can be seen in many different situations. With experiment and without experiment, like run report or some kind of machine that applies the rules. And like we walk from the boat to the land, and we see when we walk forward and boat will move backward, for example. So students can see many cases and then to formalize or to formalize the conclusion of the law. But before you state about the equations, momentum before equal to momentum after, where is that relationship from? How do you know that relationship?
I will remind students the law of conservation because it is the verified law. So I have the law, and students should verify it.
Okay, so you start with the lesson with already the results of the previous lessons. Somehow students already deduct the relationship between mass and velocities of the system before and after the collisions, and this lesson is only to verify it. But to check the questions or to check the tasks you have to prepare for the exam today, it's up to teach the whole lesson. So you should start with your presentation a little bit broader view. So you investigate in a situation where they see somehow the relationship between mass and velocity of the systems of the object before and after collisions, and so you have a better question about the relationship between it, and then you apply the second law, the third law, and some other knowledge to arrive at that conclusion. It's not necessarily long because you want to focus on experiment, but the task is to teach the whole lesson. So this I'm messing the first part a little bit. Say 1 minute and then keep going this way.
Okay.
So when you come to a professor, you have to check what is required for you entirely, and then you have to make sure to meet all the requirements. And of course, you then you make a focus, but at least you have all the required for it. So in this case, the first part is missing.
Sorry.
Okay.
Thank you.